Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the instructor for the lecture. And today's topic is going to be web security. So let's go ahead and let's start off by talking about the developer mindset you should have whenever you're building a project. Okay, so first things first is you should always prepare for the worst and hope for the best. Because no matter what you do, no system is 100% secure. Okay, so that being said, before you start building any project, you should always assess the project and see the level of security needed. Because not every project needs the same level of security. For example, if you have a restaurant that reaches out to you and they just want like a static menu website and that's it, they don't need anything else, then that maybe wouldn't need a high level of security, right? However, if there is, say, a restaurant who wants a menu with, credit card transactions and user accounts and passwords and all that, then yes, we would definitely need to heighten the security on that. Okay, so it's not one size fits all. So definitely develop accordingly. All right, so next, let's talk about developer accountability. Okay, so when you build software projects, some of them fall under specific scopes that are legally bound by law to follow certain procedures. Okay, so two of the biggest are PCI compliance and HIPAA. Okay, so PCI compliance is anything to do with credit card information, online transactions in that way. Okay, and the best and easiest way to stay PCI compliant is never let a user's credit card information hit your server. Okay, so you might ask, well, how do I build an application, which without, that server interaction? And the answer is a lot of times you're going to use a third-party service such as PayPal or Stripe, and they're going to handle all that for you and take on the accountability themselves. Next, for HIPAA, that's anything to do with health information, right? And so if you're building health software, you'll definitely need to make sure that you are, up to date on all the latest, specifications. Okay, so you can view the official PCI specs by going to PCIstandards.org and the HIPAA specs by going to the HHS.gov. Okay, all right. So next, let's go ahead and let's talk about actors. Okay, so when you build your software, it's really hard just to think, I'm going to build this in a way where it's just going to protect it from everything, right? It's hard to think of things that way. So instead, think of things in terms of actors. Okay, so you've got good actors and you've got bad actors. So good actors would be users that use the website for its intended purpose. Okay, and someone like a bad actor would be maybe an internal employee who uses customers' credit card information for their own, purposes, right? So think in terms of actors and building the software, and that kind of helps guide you in the right direction. Right. Next, let's talk about trust boundaries. Okay, so trust boundaries are divisions between software that have different privileges. Okay, so we have client server roles, network machine roles, encrypted channels, authentication, and areas of responsibility within the system. Okay, so let's go ahead and explore, how all these apply. Okay, so we're going to first start off by talking about a computer network. Okay, and if you don't know what a computer network is by now, let's go ahead and cover that. So it's a collection of, excuse me, it's a collection of computers connected by a transmission medium. So when you write software on the web, it'll end up being hosted on a web server, and clients can connect to your server via web browsers, phones, apps, and all that good stuff. And from there, you have your computer network. Okay. Next, let's talk about how you can secure channels between requests. Okay, so anyone on the same network can view all the traffic you're sending and receiving. Okay, so in order to have a private conversation between clients and servers, the channel must be encrypted. This can be accomplished using a TLS certificate and redirecting our traffic from HTTP to HTTPS. Okay, so a couple of places you can get this TLS certificate are Symantec. Okay, they're one of the bigger providers, as well as Komodo here. Oops. There we go. Okay. And of course, there's others besides these two. They're just kind of, some of the bigger ones. All right. So next, let's go ahead and let's talk about securing your API endpoints. Okay, so because endpoints are generally publicly exposed, it's a good idea to set up some additional logic to verify the incoming API requests. For example, we go to github.com, it allows us to view all public resources, right? We can view other repositories, but we can't view any of your own because we're a guest still. And as soon as we sign up for an account, we then become a user. When we log in, we can view our own resources as well as public resources. And then if I'm part of an organization or something with a role, I can view even more specific resources, right? So the point here is that GitHub isn't just allowing any role to access any endpoint, right? They're all set up, in that specific manner. Okay, so more on API security, rate limits. Okay, so imposing a rate limit for requests made to your application API is a good way to ensure your site from getting attacked with several requests at once. Okay, so let's go ahead and let's explore it. So GitHub has an API rate limit in play for their API. So let's go ahead and let's make a request there. So I'm going to go to my command line here. I'm just going to drop that in like so. And we can see it makes that request. And we can see that my rate limit started off at 60. And after the request was made, now I only have 59. Okay. And so this way I can only make, I think it's like 60 requests in an hour. So it's going to be impossible for me to hit it with, a bunch of requests at once and flood their servers. Okay. So this is an example of security in play. All righty. So moving right along, let's go ahead and talk about DOS attack. Okay, so the denial of service attack is where we flood the targeted machine or resource with many requests at once in an attempt to overload the system, prevent some or all requests from being fulfilled. Okay, so this goes back to rate limiting, right? If GitHub didn't have a rate limit, they could be subject to a DOS attack. Okay, so this is a technical term for that. So our prevention methods are throttling. Okay, so this is, limiting bandwidth. Rate limiting, which as we saw is limiting the number of requests that can be made to an API endpoint in a specific, time range. And then web traffic monitoring. Okay, so they got a lot of tools out there for this. So you can have real-time traffic updates, just in case you see a mass flux in a matter of seconds or minutes, you'll know that you can take the appropriate action. Okay, next, let's talk about an XSS attack, also known as cross-site scripting. Okay, so it's a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side scripts, typically through an input of sorts, into web pages viewed by other users. Okay, so how we can prevent how we can prevent against this is to use something called sanitization. Okay, so they've got many libraries out there for whatever languages you're using, and that will sanitize your inputs and make sure that they are raw text or numbers, right, or the actual valid data type and not actual script tags. Okay. Next, let's talk about SQL injection. Okay, so SQL injection is a technique used to attack data-driven applications in which nefarious SQL statements are inserted into any entry field for execution. So, for example, to dump the database contents back to the attacker. Okay, so the thing with SQL is it's so close to plain English that a lot of times we can put it in an input field and submit it, and that'll be just fine, right? But we don't ever want that executing in our database. Okay, so how we can prevent against this is, there it is again, sanitization. Okay, make sure we actually check the input for red flags such as this, or we could use some sort of object relational mapping tool. Okay, and so moving on forward, let's talk about file uploads. So file uploads is one of those securities that not a lot of people are aware of. It actually happens a lot. Okay, so what happens is an attacker can upload an executable file such as a PHP file and then call the corresponding URL from the web browser. And now they're running code on your server. Okay, so to prevent against this, you can use a file type detector. Okay, and so this is similar to sanitization, right? You're just looking at your file uploads instead of your form submissions and input submissions. Okay, so and then of course you can filter it out and say I only want PDFs or JPEGs or PNGs, right? Whatever file type you want to allow, you can set those up accordingly. Alrighty. So next, let's talk about ARP spoofing. Okay, so ARP spoofing is a technique by which the attacker sends a spoofed address resolution protocol into a local area network. Generally, the aim is to associate the attacker's MAC address with the IP address of another host, such as the default gateway, causing any traffic meant for the IP address to be sent to the attacker instead. Okay, so you can think of this very much like an interception, right? And so this is again where we want to incorporate the TLS certificate and redirect our traffic from HTTP to HTTPS. Okay, and then it creates a secure tunnel, and we don't have this spoofing going on. Next, let's talk about DNS spoofing. Okay, so DNS spoofing is a form of computer security hacking in which corrupt domain name system data is introduced into the DNS resolver's cache, causing the name server to return an incorrect IP address. This results in traffic being diverted to the attacker's computer or any other computer for that matter. So prevention methods again, here it is, TLS certificate. I'm sure you're starting to see a pattern by now. Okay, TLS certificate solves many issues, and the main is just protecting our network requests. Okay, so make sure that this is not something you skip. Although it is an extra step, it's definitely a super necessary one. All right, next let's talk about firewalls. Okay, so a firewall is a network security system that monitors and controls the incoming and outgoing traffic based on a predetermined security rules. It's always a good idea to make sure the machine your server is running on has one set up. Okay, and most of the time, if you're working for a company, right, they're gonna take care of that for you. But maybe if you're doing your own freelance gig or something else of that nature, you're gonna need to incorporate a firewall, right? So make sure you have those set up, and they're very straightforward. Come with graphical user interfaces and all that to configure. All right, now let's talk about having a plan B. Okay, so no system is 100% secure. Okay, we said that at the very beginning. So it's a good idea to back up your data and your OS just in case your service, something happens, and then you don't have to have it interrupted, right? So as well as having backups, you should have an emergency checklist for your team. So they know what to do in the case of an outage. So if you're not there or something, they can still take corrective action. Okay, so be prepared for the worst. Next, talk about organizational privileges and how you designate those. Okay, so as there's oftentimes a large number of hands involved with building a single software project, it's often a good idea to restrict access to things on an as-needed basis. For instance, a developer may have access to modify the code, but not to touch the production servers. And the operations team might have access to modify the server environments, but not the code. Okay, and this just goes back to, people being human and the way they leave jobs, right? Like if someone gets fired or someone's quitting, right, and it's not on good terms, maybe they're a developer, have access to everything, and they just go in on their last day and nuke the database, right? So this is where you have to be really careful about organizational privileges and who you give those to, because really, you're playing with fire sometimes if, you just, give them out to everyone. So designate carefully in that regard. All right, now let's talk about protecting your passwords. Okay, so when encrypting passwords, there's several ways to go about this, okay? Several different languages, libraries, tools, blah, blah, blah. Okay, so the way we're going to be talking about is a simple hash algorithm. Okay, so encrypting passwords, first what we do is we take our password, let's say, you know, it's coder camps, and then we add a salt, okay? And a salt is just a long random sequence. And then we hash it, okay? And we use an algorithm to verify that block the content has not changed. And what this does is two things. It makes it nearly impossible to guess the password without knowing the salt. And even if the attacker gains access to the salt, they won't be able to use the pre-computed hash tables to get the password out. They'll have to know the actual real password itself, or the salt will be useless. Okay, so as well as encrypting our password when we store it in our database, it's also good to enforce some sort of password strength rule. Okay, because people are lazy and they'll put 1, 2, 3 for their password, or something easy, and then hackers will get in and it'll make it look like you're not doing your job, right, as the software dev. In reality, they were just not very responsible as a user. So help users help themselves in enforcing that minimum strength rule, or whatever else it may be. Okay, and as well as, you know, just doing regular authentication through, you know, maybe just, you know, their email, password, all that good stuff. You could also add two-factor authentication. And what this is where, you know, they send like a text message to maybe a device like your phone, and, you know, you have to enter that code into, you know, an interface, and, you know, depending on the outcome, it'll grant you access or not. Okay, and the reason for this kind of authentication is for highly sensitive institutions like banks, right, financial institutions, where they need to make sure your you know, account is secure at all times. If, for instance, you lost your computer, well, you know, that means, you know, the hacker could have access to all my bank accounts. Okay, so what the software does for a lot of these bank accounts is, you know, they have their machine they log in on, but they also send the code to the phone, and they have to authenticate that way too. Okay, so that being said, it makes it a lot harder if maybe the attacker only stole the laptop, but they didn't steal the phone, right? This is way they can't get into, you know, multiple accounts. Okay, so depending on the kind of software you're building, you might want to add two-factor authentication just as an extra layer of security. All right, let's wrap it up by talking about security resources and where you can find and look up information about, you know, recent events and all that good stuff. Okay, so first let's start with this government maintained database. Okay, and this is called MBD. Okay, and you can just come here and check out vulnerabilities, you know, all their latest reports, all that good stuff, and yeah, keep up to date on what's going on. You can also check out OWASP. This is like the Wikipedia of you know, incidences and, you know, precautions to take in regards to certain approaches in tech. And Verus is a community maintained database, and similar to MBD in the way that, you know, just stores events and recent incidences. Okay, so let's go ahead and take this time to open up the floor, and let's see if anyone has any questions. Okay. So the floor is open. You are free to ask away. No questions today? Okay. Well, if that's the case, thanks everyone for coming. Have a great day and happy coding.